Good evening, welcome to Column Cymru, and today my name is Grant Mackenzie and we're going to go through Maths A-Level, where we will be looking at the topics of binomial, arithmetics, sequences, geometric sequence, normal sequences. Over the next sort of two sessions with the Maths A-Level, for the next session next week, I'm going to be covering parametric equations, differential equations, and implicit differentiation. And then on the last session for this sort of season, I'll be looking at past paper, probably a 2018 WJC past paper, where I'll be covering all of the topics that would be sort of in your exams, so that you can have a look at the different way in which we can answer them. If we get started today, I'll start with the binomial. Just change my pen to black. There we go. So here we have the expansion. Find the binomial expansion of f of x, which is 3 minus 2x to the power of minus 4. Now, you've done the binomial previously at AS level, but the the powers then for the binomial were always a positive integer. And it was a set way in which you could use Pascal's triangle, so on. This is one, if you had, say, to the power of 5, then you'd have 6 entries or 6 terms. With binomial expansion now, it's infinite. So it's to the power of minus 4, or it's to the power of a fraction. So it's going to be a negative integer or a negative fraction, or it's just going to be a fraction. If you have a look in the formula booklet, the expansion is in the form of 1 plus x to the n. It's important that you've got that 1 plus x, that 1 specifically. And then it is equal to 1 plus nx plus n minus 1 x squared over 2 factorial. I'll put another one in, although really in most cases it doesn't really need it. Over 3 factorial x cubed dot dot dot. Okay, that is the binomial expansion in the formula booklet. And as I said, the way it is worded, or the way it is put, is you have to have that constant there of 1. For this example, we don't have that. So it says find the binomial expansion of f of x in ascending powers of x up to including the term x squared, giving each coefficient as a simplified fraction. So the first thing we're going to have to do is we're going to force the factorizing of this, so that instead of that 3 being there, we have a 1. So I'm going to take out a power of 3. I'm going to take out a factor of 3 from both. So that's going to be 3 to the power of minus 4. Then it's going to be 1 minus 2 over 3x, all to the power of minus 4. Now you can put 3 to the minus 4 straight in the calculator, and that'll give you an answer of 1 over 81. So we are going to expand this, and then we're going to times all of it from 1x and x squared by 1 over 81 to give us that. If I move this over to the other side, in the expansion of 1 minus, and you can even put a plus there, minus 2/3 x to the power of minus 4. And then we're going to substitute it into this formula where we have 1 plus n is minus 4, which I'm not going to put in as a bracket, and then it's going to be minus 2/3 x plus minus 4. Minus 4 minus 1 is minus 5. Minus 2/3 x all squared, all over 2 factorial. Now 2 factorial is just over half, or time divided by 2 is 2 times 1. Factorial means that you would multiply that number in decreasing sort of steps. So if you had 5 factorial, it is 5 times 4 times 3 times 2 times 1. In this case, 2 factorial is just 2 times 1. Tidying this up, we have 1 minus and minus still makes it a plus. So we're going to have 8. 2 4 8 over 3x. Again, minus 2/3 is going to go, when you square it, it's going to be a positive, and then you've got minus 4 times minus 5 is going to give you 20. I'm going to put 20 over 2. You put a little dot for times, and then that is going to be 4 over 9 squared. It's 1 plus 8/3 x 40 over 9. Great. So now we've got the expansion from the blue part over here. We're then going to fill it back in, saying that 1 over 81 multiplied by 1 plus 8 over 3x plus 40 over 9 squared, so that we have 1 over 81. So we have our expansion of 3 minus 2x to the minus 4, 1 over 81 plus 8 over 243x plus 40 over 729 squared. And there you go, it's done in full. I think the fractions are simplified. If they're not, if you put them into your calculator, then it'll simplify them out for you. And there's your answer. Next one. Okay, here we have use the binomial expansion in, again, ascending powers of x of 1 over the square root of 1 minus 2x to show that that is the case. Yeah, let's get started. We have then 2 plus 3x multiplied by 1 minus 2x. I'm going to bring that up so it's to a power of a half. Sorry, to the power of minus a half, because it's the square root of 1 minus 2x. Bring it up on top, changes from a positive power to a negative power, and then obviously the square root is a half. So using the binomial, I'm going to then work out this section, and then I'm going to expand it with the 2 plus 3x, and I'm hopefully getting the 2 plus 5x plus 6x squared. Notice the little squiggly white lines there. It just means the approximation. It's telling you they know there's more terms, but it only wants you up to the x squared term. So again, if you straight away put 1 minus the 2x to the power of minus a half, that is equivalent to, if you want to write out the formula first of all, so it's 1 plus nx plus n minus 1 x squared over 2 factorial. And then second one, notice that it has got a 1 first of all, sort of directly inside the bracket, so I don't have to manipulate it. Whereas with the previous question, it had a 3 there, so I had to manipulate it so that I'd get a 1. So this is, and again, if you want it as 1 plus, and then in brackets, the minus 2x. Brackets. 1 plus, and this is minus a half. It's 2x. Minus a half, 3 over 2. Again, it's going to be minus 2x all squared all over 2 factorial. Now, I'm used to expanding or sort of working these out without using a calculator, because they used to be on the non-calculator paper. Therefore, how I would work this out is these 2's would go with this 2 because it's 2 squared, so it actually be 4. These plus minuses, so it's going to be 1, so it's going to be plus x, it's going to be a plus. So the minus and a minus will make that plus 3, so that's going to be plus 3 over 2x squared. As I say, you can stick that straight into your calculator and that would work it out. So minus 0.5 minus 1.5 times minus 2 all squared divided by 2 would give you the 1 plus. So just turn over my notes, would give you the 1 plus the x plus 3 over 2 x squared. So we've now done that section. So we can still carry on. So once we've done that, going back to the back pen, we have 2 plus 3x. Now our expansion, 1 plus x plus 3 over 2x squared. We've been asked to expand up to the x squared term. So 2 is going to be multiplied by each of these terms. So we have 2 plus 2x plus, well, 2 times 3 over 2, the 2's will cancel, so I've got 3x squared. And then 3x, I only need to multiply by these two terms because I only have to go as far as x squared. So it's going to be plus 3x plus x squared. And simplifying it down, we have 2 plus 5x plus 6x squared, which is as required there. The second part is the one I think most students find the most complex. Is we have to substitute x equal to 120 or 1/20th into that equation, and then from that we obtain approximation to root 10, and we must give as a fraction in its simplest form. So let's go about it. I am going to use the way I've written it up here because I think it's going to be a lot easier for me. So we're going to write it as 2 plus 3 times 1/20th. And then it is 1 minus 2 times 1/20th, or minus half. That is equal to 2 plus 5 times 120 plus 6 times 120 all squared. Okay, so that is pretty much all I've done is substituting. Now I need to get this to look like root 10 on the left hand side equals a fraction on the right hand side. So root 10 on the left hand side, fraction on the right hand side. Let's tidy it up. Again, with the calculator, it can easily be put into this section and also on the right hand side. However, because we want it in terms of a fraction, I suppose calculator doesn't know, so it's not a big deal. But this is going to be 2 plus 3/20ths. So then that's going to be the same as 40 over 20 plus 3 over 20 in that bracket. So I've just moved 2 as 40 over 20. And then it's going to be 1 minus 1/10 minus a half. And then on this side, again, stick it straight in the calculator. So it does actually need to be under 400ths, and then I'll simplify it later. So I've got 800 over 400 for 2. This is going to be 5/20ths, and then times it by 20. So 5 is going to be 100, 400. And then 1/20th squared is 1 over 400, so that's 6 over 400. Tidying up, we have 43 over 20 times 1 minus 1/10 is 9/10. And then on this side, we have 906 over 100. Okay. 9/10, my apologies, is to the power of minus a half. Just concentrate on the 9/10 part. What I'm hoping you can see, the minus sign means that I can flip it. So that becomes 10 over 9 to the power of a half. If I move using a different kind of pen, let's go to green. So if I flip it, I now have 10 over 9 to the power of a half, and that is equal to 906 divided by 400 times 20 over 43. Getting it. I'm going to put a line here so that I can block it off. So then that's the square root of 10 over the square root of 9, and that is equal to, I put the actual, if I put dot, 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 and then you can see at the end, dot, 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 and then we have root 10 equals 3 times this bracket here. So that we have root 10 is equal to 1359 over 430. Now I put this into the calculator and it comes out as 3.160, I think. And then I put root 10 into the calculator and it comes out as 3.162. So as an estimation, it's not a bad estimation. So that's the binomial done for you. Next, we're going to look at sequences. So we are going to look at arithmetic and geometric. Before we do that, we're going to have a look at a little bit of the notation. Okay, so here we have a sequences, remembering that U stands for the term and that S stands for the sum. Just checking time. So a sequence U1, U2, U3 is defined by UN equals 3n minus 1. Find the values of U1, U2, and U3. So notice this little n here and this n here. So what you're going to do is you're going to put U1, so n is equal to 1. And that is going to be 3 times 1 minus 1, which is equal to 2. Then you're going to do U2, 3 times 2 minus 1, 6, that's going to be 5. And then you're going to do U3, that's going to be 3 minus 1, which is equal to 8. That's for the first part. Now it says find the sum. So sigma, most of you would have seen this when doing spreadsheets. Sigma stands for the sum of all of the terms, un, from n equal to 1 to n equal to 40. So basically, this here means find the sum of the first 40 terms. Okay, that's what that means. N stands for the lower, this bit here stands for where it begins. I'm going to put over it. This is where it begins, and this is the term number which it ends on. What you can do is we can look back at the sort of the original, and what I'm hoping you can see is that it adds on 3 every time. So this is actually an arithmetic sequence. And it being an arithmetic sequence, we can use the formulas of arithmetic. So we can use Sn equals n over 2, 2a plus n minus 1 d, where a equals the first term, d is equal to the common difference, and n is equal to how many in the sequence. So for this question, we've got the first term, which is equal to 2. We've got the common difference, which is equal to 3, and we want to find the first 40 terms. So n is equal to 40. So this would, S stands for summation, sigma stands for also summation, so you're adding up. So you're going to do S of 40 equals 40 over 2 times 2 times the first term, which is 2, plus 40 minus 1 times 3. And again, it's a case of putting it into the calculator. Now, a little tip is, if you write down the formula you're using, and then you make a slight mistake in, say that 2 there, I accidentally put a 3 in. You would still pick up a method mark because you've written down the formula, you're telling the examiner, this is the formula I need to use, this is the formula, I know I need to use this formula, but then I've done an error, mathematical error somewhere. You will pick up the method mark and potentially follow through marks later on. If you don't put down the formula, you will not get the method mark, and therefore you will not get any follow through marks. So I know it can be a bit of a pain, but I always highly recommend that you write down any formulas used, because then if you do make a mistake, same with differentiation, chain, product, quotient, chain not so much, product and quotient rule, you write them down, you put the correct information in, you're telling whoever's marking it that you know what you're doing, but you've just made a mistake. Either it's a copying mistake or you're through the differentiation, you weren't able to differentiate it correctly. If we then work this out, we're going to have 20, it's going to be 4 plus 39 times 3, and that will give us an answer of 2,420, which is the end of the question. It's only a 5 mark. But I wanted to draw your attention to the notation and how in which it's written in terms of the U1. Another one, what it could be sort of used, it's all sequences. If you have a look at the sort of scheme of work, it's sequences, arithmetic, and geometric, and then it's using. So we have a sequence is defined by U1 is equal to K, where k is a constant, and then we now have un plus 1 equals 4un minus 3. So basically what that's telling you is, if you put n equal to 2 now, it will say that this would be u2 is equal to 4u1 minus 3. Okay, that's what it's saying. And then if you wanted to work out u3, it's going to be 4 times u2 minus 3. So this part is telling you use the previous term and then go from there. So with this sequence, you have to know what each of the terms are before you can progress. You have to know what the previous one is before you can progress. And it might not be an arithmetic, and it might not be a geometric. It could be something completely different. It should be. So find u2 and find u3. So we know that. So using these formulas, which we've just sort of done, I'm going to then put this is 4 times u1 is equal to k minus 3, which is 4k minus 3. And now to work out u3, sorry, it is going to be 4 times u2. If I put a bubble on. u2 is equal to 4k minus 3. That is also minus 3. So u3 equals 16k minus 12 minus 3. So that is 16k minus 15. There's my 3 marks. I've worked out and I've also simplified it. Can't do anything simpler than that. So it's done. It is then given that the sum, again, sigma, for n equal to 1 to n equal to 3 of un. So that basically means that the sum of n equal to 1 to 3 of un means u1 plus u2 plus u3 is equal to 18. From this, find the value of k. Well, we know u1 is k, we know u2 is 4k minus 3, and we know u3 is 16k minus 15. So it's a sum, so we just add them. So k plus 4k minus 3 plus 16k minus 15 is equal to 18. So we have 21k minus 18 equals 18. Simple equation, 21k equals 36. K equals 36 over 18. Sorry, look at the previous 18 up there. 21 comes underneath. 36 over 21, which can be simplified. It doesn't ask, but it can be simplified because 12, 7. So k is equal to 36 over 21, which is equal to 12 over 7. Right, let's get on to a sort of another sequence which brings in the arithmetic. There we go. Check in on time. Yeah, good, 20 minutes. So the sequence u1, u2, u3 is defined by u1 equals 4, and then again is this un plus 1 equals 2 over un. So it's the previous answer. And they told us that u1 equals 4, otherwise we couldn't really go any further. Write down the values of u2 and u3. So if I put u2 equals 2 over u1, which is 2 over 4 equals a half. Then u3 equals 2 over u2, which is 2 over a half, which equals 4. Ooh, wait a minute. So u1 is 4, u2 is a half, u3 is 4. I know the answer, but I'd like to sort of see it sometimes, especially when you've got described the behavior of the sequence. I know it's only on a mark, but it's still good to sort of put it in. So then it's going to be 2 over u3. So 2 over 4 equals a half. So now you can say that any sort of any odd term is going to equal 4, and any even term is going to equal a half. So describe the behavior of the sequence. It's repeating, it's a periodic, it's cyclic, periodic, cyclic. Anything along those lines would be good. I have seen one where without any further calculations, work out the sequence u of 205. Because that's an odd sequence or odd term number, then you would say that that is equal to 4, and so on and so forth. And then we get into the arithmetic progression. So if you now remember, we have un a plus n minus 1d. We have Sn is equal to n over 2 2a plus n minus 1d. So those are the formulas. Because they're arithmetic, geometric, when we go into that question, I'll sort of write those down as well. So these are the two formulas that we're going to use. We're told it's arithmetic. The 9th term is equal to 18, and the sum of the first 9 terms is 72. So U9 is equal to a plus 9 minus 1 is 18, and that is equal to 18. And column there, S of the first 9 terms, so S of 9 equals 9 over 2, 2a plus, again, it's 8d, and that is equal to 72. Basically, what you got here is simultaneous equations. You've got two unknowns, two equations, a and d on both occasions. How you solve them is entirely up to you. You can expand them, you move the 2 up, so it's 144, and then divide that by the 9, so it makes it a little bit easier. How I would sort of do it would be 9 over 2 a plus 8d equals 72, and then I would just replace this section here with 8d. 72 divided by the 2. If I move that over across and check. So we would have then a plus 18 equals 72 times 2/9. 72 divided by 9 is 8 times 2 is 16. Move that across, a equals 16 minus 18, which is minus 2. What we're trying to work out, find the first term and the common difference. We found the first term, and then we need to substitute that back in. So for a plus 8d equals 18, we have minus 2 plus 8d equals 18. So we have 8d equals 18 plus 2, d equals 20 over 8, which is equal to 2.5. So we have our first term, a, which is minus 2, and our common difference, which is 2.5. Going on to the next question. Now, they do like a modeling question. Now, the modeling question could be arithmetic, it could be geometric. So this one, I think I've got a couple of each. Jess started work 20 years ago. In her first year, her salary was 17,000. Her annual salary increased by 1,500 or 1,500 each year, so that her annual salary in year 2 was 18,000. In year 3, it was 20,000. So forming an arithmetic sequence. First thing I do, before I do anything else, I would write down that my first term A is 17,000, and that my common difference D is 1,500. I won't put spine sentence in there because it just detracts from the numbers. Okay, so this continued until she reached her maximum annual salary of 32,000 in year K. Her annual salary then remained at 32,000. Find the value of the constant K. Okay. So we're looking, or we're saying that UK is equal to 32,000. So using the term number, that's what we're looking for. We've got 32,000 equals, if you want to write, as I said, you might as well get used to sort of writing the formula. So it's going to be A plus, and n minus 1 is K minus 1 D. So 32,000 equals 17,000 plus K minus 1, 1,500. You rearrange this so that you have K minus 1, 1,500 equals 32 17,000, 17,000. So k minus 1 equals 15,000 divided by 1,500, which is equal to 10. So k is equal to 11. So we know that k is equal to 11. So the first 11 years of a salary is an arithmetic progression or an arithmetic sequence. Because if you have a look, her annual salary then remained the same at 32,000. So after 11th year, which is it's increasing up, 12th year it's 32,000, 13th 32,000, 14th 32,000, all the way up to 20,000. So calculate the total amount that Jess has earned in that 20 years. Well, for the first 11 years, because it is stick progression, we can then use S11 equals n over 2 2a plus n minus 1d. So then that's going to be 11 over 2 times 17,000 plus 11 minus 1. So that this then is equal to 269,500. So to have the total 20 years is 269,500 plus 9 times 32,000, which is equal to 557,500. But so over $500,000. So in that 20 years, she has earned over $500,000, 557,500. That's it. The only thing I would say with this, what a lot of students forget, is that the 20 years don't form an arithmetic sequence. So they try and do S of 20 and put it all in. So they're going to have issues. Or they might put it of S of 10 in, but you have to remember that would only then be, so it's 10 years at that, and then it must be 10 times 32,000 if you're doing that way, which isn't a problem. Okay, question number, I think this is my last arithmetic sequence, which is untimely, and then we'll go on to the next. So the first three terms of arithmetic sequence are 60, 4p, and 2p minus 6, respectively. Show that p is equal to 9. So we have, if that's the case, so a is equal to 60, that's the first term. The common difference d is 4p minus 60, or it is also 2p minus 6 minus 4p, because obviously the common difference is how much that it's increasing by. I'm going to put this one in brackets. So if we equate those, get rid of obviously the d, and then just work them out. So we have 4p minus 60 equals 2p minus 4p minus 6. That would give us minus 2p, and then it would be minus 2p taken over is 6p equals the minus 60 goes to a plus. So I got plus 60 minus 6, so it's going to be 50. P equals 54 over 6, which is 9. And hence we've proven it's 9. So if I put A there. Find the value of the 20th term of this series. Well, the 20th term then would be a case of U20 equals A plus N minus 1D. So it is 60 plus 9. The common difference was 9. So that would give us work out P, which is 9. So I'm going to apologize. I now need to, before I move on any further, I need to work out what D is. P is 9. And again, there's one of your mistakes. So I need to sort of see, so that's 60. And the next term is 4 times 9, 4 nines are 36. So that is a common difference of minus 24. Just to check that is the case. 18 minus 6 is 12, which is minus 24. So the common difference is minus 24. So I got 60 plus 19 times minus 24, which will give me minus 396. And then it says, prove that the sum of the first n terms of this series is given by the expression. So again, it's part C, using Sn equals n over 2, 2a plus n minus 1b. This is going to be equal to n over 2 times 60 plus n minus 1 minus 24 brackets. Because then I don't want to mess that bit up. If we expand this, the 2 into here is going to cancel. They'll cancel for that bit. And then it's just going to be left with 60n. Here, the 2 will cancel with the minus 24. So this is going to be minus 12n times n minus 1. So then this is going to be 60n minus 12n squared plus 12n is 72n minus 12n squared. 12 is common as well as an n, which will then be 6 minus. Again, I'll probably put QED for that. Okay. Yes, down to a geometric. Okay, so in the first month after opening, what we're doing for time, I hopefully get the next 2 done. I've got 3 more questions. These are geometrics. I'll try and get these 2 done, and then the last one I'll put up with the PowerPoint. In the first month after opening a mobile phone shop, sold 300 phones. A model for the future. Sales assumes that the number of phones sold will increase by 5% per year, so that 300 times 1.05 will be sold in the second month. And then 300 times 1.05 squared in the third month, and so on. Use this model calculate. So again, this is a geometric where the common ratio is 1.05. So we have the formulas that we need is un equals a r n minus 1, and then the sum n equals a 1 minus rn over 1 minus r. I did forget to mention that there are 2 proofs still in which you have to know. The first one is the sum of the arithmetic, and the second one is the sum of the geometric. All of the proofs will be taken out. The other ones were small angle forms and differentiation from first principles of sine and cos, and also the show that root 2 is an irrational number. Right, the number of phones sold in the 24th month. So this is U24 equals A is equal to 300. The common ratio is 1.05, and n minus 1, well, that's 24 minus 1, so it's going to be 23. So U24 is going to be equal to 921. And then it asks the number of phones sold over the whole 24 months. So it's a summation. So this is part A, and then part B is S of 24 equals 300, 1 minus, excuse me, 1.05 to the power of 24, all over 1 minus 1.05. Now, it's just a case of shoving that straight into the calculator so that you would have this as 13350. So that's 13,350 over the 24-month period would have been sold. The next question is a little bit more tricky and involves logs. So in introducing the logs, this model predicts that in the nth month, the number of phones sold in that month exceeds 3,000 for the first time. Right? So we have to find where it exceeds 3,000. How we would do this would be saying that un, so see, is greater than 3000. UN is, well, we know that it is 300 times 1.05 to the power of n minus 1, and that must be greater than 3000. Tidying this up, the 300 goes over, so we've got 1.05 power of n minus 1 is greater than 3000 divided by 300 is 10. Can't do much else here except for taking logs of both sides. Take log natural sides. Doesn't matter what base it is, as long as it's consistent. So we now have log of 1.05 to the power of n minus 1 is greater than 10. Put that down here so we can move over to the other side. Oh, sorry, not 10, it's log 10. We now need to use the power rule. In using the power rule, the n minus 1 comes underneath, and we have log of 1.05 greater than log 10. And then n minus 1 is greater than log 10 over log 1.05. N minus 1 is greater than 47.2. So n must be greater than 47.2 plus 1, so n must be greater than 42. Therefore, n is equal to 49. So the 49th month is when it would be greater. And you could put that into your calculator by, well, you could try it into your calculator by doing 300 times 1.05 to the power of 48, because obviously 49 minus 1. And that would be, I think it's 3,100. And if you did 40, the power of 47, it was 2,800. Okay, so taking logs doesn't matter which base you have in there. And the next question, as I said, I'll probably start it and then we'll see how far we can get with it. This is one of the proofs that I was on about that you have to show. So we have a geometric series. It's first term A, common ratio R, prove that the sum of the first terms of the sequence is so. Right, how you would do this is you would write it out. A plus AR plus AR squared plus dot dot dot. Then it's going to be ARn minus 2 plus ARn minus 1. Then you would times it all by R. So RSN equals AR plus AR squared plus AR cubed plus dot 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 ARn minus 1 AR to the n. Then you would subtract. So take away. In taking away, you would have Sn minus Rsn. What I would hope you would see in the sort of subtraction is that that would cancel. So what you have left is on this side, you have A plus ARn. If you then factorize, you have Sn 1 minus R. A is 1 plus. Sorry, when you're subtracting, you take away. You would have A R to the n. So then Sn equals A 1 minus R to the n over 1 minus R. Parts. So a liquid is stored in a barrel. Due to evaporation, the volume of the liquid in the barrel at the end of the year is 7% less than the volume at the start of the year. At the start of the year, a barrel is filled with 180 liters of liquid. Show that the amount of liquid in the barrel at the end of 5 years is approximately 125.2. Now, this is a common mistake that if I put that as A and put that as B, how you would sort of do this is you would show that the first term is not 180, but is actually 180 times 0.93, because it says at the start of the year, it's 180 litres, but at the end of year 5, so it means you need to do the start of the end of year 1, which is equal to 180 times 0.93, which is 67.4. So then you're going to do ARN minus 1, which is 167.4 times 0.93. Because 5 minus 1 is to the power of 4, which is 125.2 litres. Now, what I will do is I'll put the rest of this question and then the last question up. Thank you very much for listening, and I shall see you.